Okay, so your handout is called the common ion chart. Now, this is not all the ions. These are the common ones. So there are a fair number that are not on this list. So if you're looking for an ion that's not on this list, one, go to the periodic table and see if where your element is. For example, beryllium. Beryllium is not on here, but it's in the family of magnesium, calcium, strontium. The calcium, strontium, magnesium are on here. So it's the same within the periodic table grouping. The ionic characters are also the same. Okay. Ions are divided into two kinds of ions, positive and negative. Positive ions are called cations. This is a new mouse, and I'm not sure I like it. Okay, so cations, that's where the number of electrons does not equal the number of protons. That means there's a charge on the atom. Okay, if there are more electrons than protons, that means you have a net negative charge. And it's called an anion. Okay, anion. Okay, if the number of protons is greater than the number of electrons, it's called a cation, positive charge. So this table is divided in half between negatives on the right, positives on the left. Now, up here in the top right, we have something called covalent. So there are two naming conventions. One is ionic, the other is covalent or molecular. You'll see the word molecular as well as covalent. Like in your dry lab, they call it molecular. Okay, so we're going to talk about covalent ions, covalent molecules first, and how to name them. Now, this mono, di, tri, tetra, etc. You're going to use that to say how many elements are in a particular formula. So let me show you what that is all about. Oh, let me back up a second. First of all, you need to determine what you're looking at. Is it ionic or is it molecular? That's test number one. To do that, ionic molecule has to have a cation plus an anion. No exceptions. So you have to have a positive and a negative. Sometimes they say a metal plus a non-metal. I like to do the top one more than the bottom one because there's some exceptions to the bottom one. But a lot of teachers will say an ionic compound is a combination of a metal and a non-metal. Remember, the non-metals are in the top right of the periodic table. Okay. If it's not an ionic compound, then it defaults to a molecular or covalent molecule. And you can have cation and cation, anion and anion. Yeah.
That's charge.
No, what happens is the negative charges balance the positive charges. In fact, we're going to see when we get to ionic naming that that's how the formula is set up, is they have to balance. So no net charge, zero charge. So the positives have to equal the negatives. For ionic, yeah, exactly.
What is a metal plus a what metal?
Non-metal.
Oh, no.
Okay, so let's look at now an example of a covalent compound or a molecular compound. Good old water. If that's too noisy, you can shut the door if you want.
Did you say word?
Huh?
Worder?
Water.
My grandma says warsh. It's a southern thing.
My relatives from the South, I never heard them say that, but anyway,
George?
they're from Dallas area. All right, so let's look at water. Now, if you look on the common ion chart, you'll find hydrogens are negative and oxygens are negative. So that does not qualify for being ionic. So then it defaults to molecular. Okay, so what we're going to do so excuse me. So covalent naming is in two parts. So the first part are going to be for H's. And if you look on your chart,
Here.
yeah, you're going to need this chart for your drying. Okay, so here's H. And O's. Okay. Now notice they're both negative. That means it's definitely not ionic because we don't have a plus and a minus, cation and anion. Okay, so we have to use the molecular or covalent naming convention to name it. Okay, so it's in two parts. This part is from the name that appears in the periodic table. So that's hydrogen. And the second part is an ide. Now, if we look at our chart again, we'll notice oxygen is an oxide, IDE, oxide. Okay, how many H's are in water? Two, so that makes it a dihydrogen. Now you can say monooxide or Now, mono is one of those weird things. If it's in the beginning, it's optional. If it's in the second part, it's not optional. So water is called dihydrogen monoxide. Now, we have two O's together. So we're going to eliminate one of the O's. So instead of saying dihydrogen monoxide, we're going to say dihydrogen monoxide. Okay? So we're going to remove one of the O's. So di means two, so we know we have two hydrogens. Mono is one, so that means we have one oxygen. Now, all these are going to have two parts, including ionic. Ionic's going to have two parts as well. So are there any questions about how we did that? Okay, so let's take another example. Let's look at uh, NO3. Now let's do another one. Let's do
Oh, I do have a question. So how did we get the mono?
there's one. Look in the top right at
One oxygen, that's one.
look at yes, there's one oxygen. Look on your chart, top right. Top right.
Mhm.
Notice there's numbers.
Yeah.
Mono is one. Okay, let's look at this compound here. Anyone know what this is?
No.
Huh? It's called laughing gas.
Oh, I know it's
And what is laughing gas called? Nitrous oxide. Yes. Okay, that's nitrous oxide is one name. There's another name. The IUPAC name for it is not nitrous oxide, actually. It is called nitrogen. Now, how many nitrogens are there? One. Now, when the mono is in the beginning, it's optional. So it's mononitrogen monoxide. Now, there's two of these. There's one called nitric oxide as well. So there's nitrous, nitric. That's nitric, nitrous. Okay,
like nitrate means that there's three.
no.
Because it has tray in it, but there's only two.
Right. We do ionic, we'll talk about that. So hold that question. Okay, so this is the official name for NO. Now, oh, and then how did we know this was a molecular covalent and not ionic? It's because we have N is on your chart negative and O is negative. There's not one of each. Okay, so do you have a question? Huh? Okay, cool.
Wait, so they're both negative?
Both negative. Look on your chart, top right. You'll find nitrogen and oxygen there. What charge are they?
Where do you see that? Nitrate?
We have look up here. Yes.
Nitrate, and that one's -3.
-3. And oxide's -2. So two negatives, that means we use the covalent or molecular convention for naming stuff.
Well, wait,
Because it's not one of each. Ionic's the cation plus an anion, positive plus negative. Okay, so most people find the covalent naming convention is more straightforward than the ionic. That's why we're doing this one first. Now, I have a bunch of worksheets, of course. Let's see now where. I moved. Oh. I have a bunch of these. Well, I guess they're gone now. It's gonna be under unit 2 anyway. I'll put those on when I go to lab. And those are gonna be, they're like 3 worksheets, ionic and covalent naming, as well as your dry lab, covalent and ionic naming.
wait, so which, worksheet are we looking for?
I couldn't find them. I have to put them back on.
Ah,
Okay, so let's go to, are there any questions about the molecular naming? So step number 1 is to determine whether it's ionic or covalent. Step number 2 is then look at the 2 parts of the name. The first one comes from the periodic table directly. The second one is an IDE version. Like N is nitride, oxygen is oxide, hydrogen is hydride. So in your handout in the top right, you'll see all the ides. Yeah. You're gonna get that on your test.
that's one aspect, right? And then step 2 is what?
Put in the words then, okay? You look at the formula. First one comes from your periodic table. Like for the water, it'd be hydrogen.
Mhm.
And then the second one is an ide that comes from your ion chart there. Okay, so let's go into ionic now. Now, ionic, we have to have a net zero charge. Because ionic are positives and negatives. And those have to balance out so there's no charge. So if we look at the common ion chart again, notice every one of those has a charge associated with it. So step number 1 is is this ionic or covalent? If it's ionic, we're going to use this convention we're going to talk about now. Notice, for example, iron. Iron the common ions for iron are iron 2 and iron 3. Iron 2 has a charge of +2. Iron 3 is a charge of +3. So that's what the Roman numerals are in there. They have to do with the charge. Now, only cations have different charges. The anions only have one charge. Now, when it's a single anion, there's a charge, but because we're in an oxygen environment, there's a lot of oxygens that are added on to those single ones, like sulfur. Sulfur exists as sulfur by itself as an ion and as an element, by the way. Sulfur is, you can add on 4 oxygens, 3 oxygens. There's a variety. Look at chlorine, same thing. 4, 3, 2, 1. Lots of oxygens in here. And these are called groups. Yeah.
I noticed that the cations versus the anions, the cations have all the metals and the anions have all the gas.
And nonmetals. And it's pronounced cat ions.
Oh, yeah.
Think of a kitty. Think of a kitty. Okay, so because of that oxygen atmosphere, oxygen permeates the anion all over the place. So there's groupings with oxygen. So that's what makes the anions more complicated than the metals. Metals are much more straightforward. There's only 2 groupings with a metal. That's with mercury, Hg2, and then at the very top is ammonium, NH4. Those are the only 2 groupings for cations. The only groupings other than those are on the anion side. Okay, so let's look at an ionic example. Where are we here? Now again, 0 charge. So if we were looking at let's write the formula for calcium nitrate. Okay, so we go to your common ion chart. We find calcium. Notice calcium is a +2. And we have to balance that +2 with some negative charges. So then we're going to find nitrate. A nitrate, NO3, has got a charge of -1. So how many nitrates do we need to balance the +2 exactly? Calcium +2. We need 2 nitrates, 1 apiece against the +2 calcium. Yeah.
So I'm looking at nitrate and it says -3.
No.
It's -3.
No, the whole thing. Okay, so his question is, he sees the 3 up there, but the 3 is not a superscript, it's a subscript. Okay, so this 3 refers only to the oxygen. So there are 3 oxygens there, 1 nitrogen. And the whole thing as a group is charging -1. So you can think of it like this. The whole thing is going to charge you -1.
Okay,
Better?
yeah, so then it's still not balancing out calcium, so we need to add another one.
Exactly. Okay, so after saying all that, so calcium. So to have a net 0, we need 2 nitrates. So we're going to go calcium. And we need parentheses because we have a group. We didn't put parentheses around it. We'd end up with like that. So we'd end up with 6 oxygens. So we need parentheses. So think of groups, parentheses. All right. So we have now +2, -2. Net charge 0. No exceptions on ionic. It's got to be net charge 0. Yeah.
So the negative. Six. And then. So that,
2 below. It's a subscript.
and so that was changed the. Top.
Yeah, because there's 2. Think of it as like that. So shorthand way of doing that is to put the parentheses with the 2. Yeah,
So I know we got the first -1, but how did we get the second?
because we have 2 of them.
Oh, so we just added, oh, okay, but when I said add another one, I thought you meant like another else. We just added the same element.
Exactly, exactly. Someone else had a question. Hand went down. Okay. All right. So you're gonna have to go from the name to the formula, formula to the name. Okay, so let's take another ionic one. Let's take
Uh,
okay, so copper nitrate. Go to the store, you can buy it as a root killer at the hardware store. Root killer is also copper sulfate. Okay, so let's write the formula for that. I notice it says copper 2. What's the charge on that copper? 2, +2. So we have nitrate we've already done. So that's not a net charge of 0. So we need 2 nitrates. So we have a -2 charge against the +2 charge. So we have a net charge of 0. Now, if you notice on the common ion chart, there's another name for copper 2 called cupric. Yeah,
So just go back to that, for the NO3, could we have, since it's like, because NO3 and NO2 both have like negative charging.
correct.
Could we like, are we able to choose for those, like, are they the same thing? So
They aren't the same thing. One's called nitrite, the other's called nitrate.
Oh,
And the reason why they're not spelled the same is because the formula is different. Okay, so notice copper 2 says cupric. Now, if you look on a food label, they don't use copper 2, they use cupric. nitrate. You look on an ag label. For example, you're gonna go buy a rootkill at the hardware store. It's not gonna be called copper 2 nitrate, it's gonna be called cupric nitrate. Now, and you're in the chemistry department, we call it copper 2. In the biology department, they're gonna call it cupric nitrate. And it's old world. There's cuprous, cupric. Cuprous is +1, cupric has got a +2 charge. Now, the reason why they got away from the cupric and the cuprous is because it's not standardized. The ic is always higher than the us, but not necessarily the same. So they did away with that and they just said copper 2. We always know that copper 2 has got a charge of +2. Very, very straightforward. The world, unfortunately, has not adopted that. Only chemistry department and physics department have adopted this. And they adopted it a long time ago. But the world, just like with the metric system in this country, have a nice day. So, in 1A and 2A, they will not talk about any of the old world names. But I give you the old world names because that's going to be your reality when you go to the store and look at a food label. You're going to use the old world names. So now you have both. Okay. All right, so that's the formula. Now, when you write a formula as an intermediate, you can write little pluses and minuses, but when you write the final formula, don't write the superscripts. Just write like that. So this is an intermediate version. That'd be the final version. Okay, let's do aluminum sulfate. So is this ionic or covalent? Okay, look up aluminum. What charge is it? +3. And what about sulfate, SO4? -2. And remember, we have to have a net charge of 0. So what are we going to do in this one? How do we handle this when we balance equations, a 2 and a 3? It's like the common denominator. Remember we did that with the balancing equations? Okay, so what's the common denominator between 3 and 2? 6. So how many aluminums do we need? How many sulfates? Because 3 times 2 is -6. 2 times +3 is 6, +6. Net charge of 0. Let's name that. V is vanadium, by the way. Okay. Notice vanadium exists. Vanadium is bottom left. Look how many vanadiums there are. There are what? 3 of them. Which one is it? Now remember, this is balanced, 0 charge. Well, what about sulfate? Are there multiple versions of sulfate? One version of sulfate, SO4, one version only. So what's the charge on 2 SO4s? That's right, -4, exactly. So one vanadium has to have a charge of what to balance the -4? +4, exactly. So when we write the name, it's going to be vanadium 4 sulfate. So that the charge is net 0. How would I write the name of that? Same thing as the prior one. What's the charge on NO3? -1. And how many of them do we have? 6. So that means this is a -6. So what must the charge in the vanadium be? +6. Look on your chart. Is there a +6 there? That's because it's an uncommon ion. So we write this as vanadium six nitrate. The 6 means it's a +6, vanadium, yeah,
So how is NO3 negative again?
on your chart. It's in the middle, on the right. Okay, so those are the 2 conventions, yeah. Yeah. Yeah, exactly. Exactly. Yeah. A non-common. The sheet I gave you says common ion chart. Well, there's a lot of ions that are not on this chart. We need a book to have all the ions. So these are the most common ones. Now, your next chemistry class, you're gonna have to memorize some of these. It depends on the instructor. Now, if you go in your book, there's a list of common ions there, which is much shorter than this, and frequently they'll have you memorize those. So it depends on your instructor, depends on which class you're taking, 1A or 2A. And here, we all have smartphones. Does anyone not have a smartphone in here? Gee, no one's raising their hand. What a surprise. So you can look up this within how many seconds? Your phone is always listening to you. And you can, yes, unfortunately, yes.
Oh, you mean like the government's listening?
Well, so is your phone. And your
I
government.
thought you meant like it's very cooperative and you're.
Don't even, you can talk to it.
Yeah. But I meant like text.
Right.
Like it's not always gonna work.
Hey, Google, what's the charge on vanadium 4?
Like I said, it's not always gonna work with you.
Hey, Google. What's the charge on vanadium 4?
On vanadium, IV is +4. In aqueous solution, the most common ion for vanadium, IV, is the vanadil ion. Text VO.
I had to wake it up.
Yeah.
Okay, so we've gone over a bunch of examples, and basically what we're going to do is do dry lab now and do the I forgot which one it is. Let me look at
You have to put it up there again, right?
huh?
So you said you had to put it back up there?
No, that's the other one. Well, in your lab packet, it's called nomenclature, but I forgot what number it is. Okay, there any questions now about molecular / covalent or ionic naming? This just requires practice, like the world is, okay? Now,